Okay, here is an application of polynomial inequalities. A position of an object moving upward or downward under the influence of gravity is expressed this way. S of t is equal to negative 1/2 gt squared plus v sub 0 t plus s sub 0, where g is the acceleration due to gravity, which you can either say is 32 feet per second squared or 9.8 meters per second squared. T is the time of travel, and v sub 0 is the initial speed. S sub 0 is the initial vertical position. So this is how we talk about falling objects or vertical motion with gravity. And so here's an example. A toy rocket is shot straight upward from the launch pad 1 foot above ground level with an initial speed of 64 feet per second. Write a model to express the vertical position S of t in feet of the rocket t seconds after launch. B, determine the time at which the rocket is above a height of 50 feet. So first thing you're going to do is write the equation. S of t is equal to negative 1/2. We're going to use 32 feet per second squared because we're dealing with feet here, 64 feet per second. So we need to use that one and not the one that is meters per second squared. Then we have t squared plus 64t. 64 is the initial speed, v sub 0, and then 1 foot is where we're going to start above the ground, 1 foot, s sub 0, the initial position. So that's our model, that's our equation. B says determine the time at which the rocket is above a height of 50 feet. So we want to know when is that s of t, that function, greater than 50. So the first thing we need to do is get everything on one side. So we're going to subtract 50 on both sides, and we'll have, after we simplify that and make it look a little bit better, we're going to have negative 16t squared plus 64t minus 49 is greater than 0. So we know that if we use the quadratic formula, we can find out what the zeros of that function are, where it crosses the x-axis. And so you punch all that in, and you end up with negative 64 plus or minus the square root of 960 over negative 32. And then that is 2 plus or minus the square root of 15 over 4. And so that is about 1.03 seconds and 2.97 seconds. And we just need to see when is the function positive, greater than 0, and when is it less than 0 on these three intervals. So from negative infinity up to 1.03, the function s sub 0, we picked 0 to check because it's in that interval, s sub 0 is negative 49. So that interval is not part of our solution. From 1.03 to 2.97, we can test s of 2, we can try 2 because that's in that interval. If we put that into the equation, we get s of 2 is 15, which is greater than 0. So that's definitely an interval where this function is greater than 0. And then from 2.97 up to infinity, if we put in, say, 3 in there, we get s of 3 is negative. So that is not greater than 0. So the only time that this function comes out to be greater than 0 is between the points, the x values 1.03 and 2.97. So what this tells us in this context is that the rocket is above 50 feet between 1.03 seconds and 2.97 seconds after it's launched. And you can see if you graph the parabola that this quadratic equation represents, you can see that that is where the function is above 50 feet, where the y values are above 50, would be between 1.03 and 2.97 seconds.